So under given data, HO is the height of object. It is 5 centimeters and it is on the plus side because the object is always put on the principal axis. So this side is plus side. So the height of object is always plus 5 centimeters. Second, what is given? Object is held 25 centimeters away from the converging lens. It means this is the distance of object from the optical center. So it is U. U is minus 25 centimeters as object is always placed on left hand side in front of the lens. So U is always negative. This side is negative, this side is positive on x-axis. So U is always negative. We will write U is equal to minus 25 centimeters. Then focal length is given. Lens is of focal length 10 centimeters. Focal length we have to write plus 10 as the focal length of this convex lens is always plus. Focal length is always on the right hand side. So it is always plus. So when we are writing the given data, we have to write signs plus or minus with the values. HO is plus, U is always minus, focal length of convex lens is always plus. So we have written plus 10 centimeters and find the position, size and nature of image. For position of image, we have to find V, that is distance of image from the optical centers. So V we have to find for position, then size. For size, we have to calculate magnification, and nature of the image we will see by position and size what is the nature of the image. So now we will start calculating this numericals. First we will write the lens formula. Yesterday you have seen the lens formula is 1 upon V minus 1 upon U is equal to 1 upon F. We have to calculate V. So 1 by V will be equal to 1 by F. This U, it comes on this side. So the sign will be changed. It will be plus 1 by U. Now putting the values, 1 by V will be equal to 1 upon, we will write the values with signs. This is plus 10 plus and this is minus 25. So we will write minus here, and when we calculate this, we will get 3 upon 50. 50 is the LCM. 5 minus, this minus will be here, minus 2. 5 minus 2, 3. 3 upon 50 will be the value of 1 upon V. We will flip it, and now 1 by V is 3 by 50. So V will be 50 by 3, which is equal to 16.66 centimeters. So in this way, now we know V, which is the distance of image from the optical center. This red color is image. We know in this convex lens, image is formed on the, in 5 cases, mirror is formed on the right hand side, and this right hand side is the positive side or plus side. So this, and here we get 16.66 as plus. This is plus 16.66. It means the image is formed on the right hand side of the lens. So this is how we get the answer of position. Now the position is the mirror is present at this point here. Now we have to calculate size and nature of the image. Size of the image, we have the formula HI upon HO is equal to V upon U. This is the height of the image, this is the height of the object. So HI we have to calculate, we know HO. HO is 5 centimeters plus 5 centimeters. So HI upon 5 will be 16.6 V and minus 25 U. When we calculate this, the height of the image will be minus 3.3 centimeters. The height of the object is 5 and of image is minus 3.3. What does it mean? By 3.3 we see that image is smaller than the object. Object is 5 centimeters and the image is 3.3. We can see this here. If it is 5, it is almost 3.3 centimeters. Now what does this minus sign represent? This sign, minus sign, represent that the image is below the principal axis. You know, this side, upside, when we are doing sign convention, this upside above the principal axis is positive side and below the principal axis is negative side. So when the image is showing negative sign, it means the image is below the principal axis. So we can say, and when the image is below the principal axis, it is always real and inverted. So this sign, the minus sign, shows that the image formed is real and inverted. So we have the answer of all these three. Find position, size and nature. Position 16.6 centimeters away from the optical center. Size, it is 3.3 centimeters, that is smaller than the object, and nature is real and inverted. This nature, it is, we can find the nature with the help of this sign. If it is sign, if it is negative, then it is real and inverted, and if it is positive, then it will be virtual and erect. So I think you understand this numerical and how to solve. Then we will draw a ray diagram. Ray diagram, we will by taking the scale, we will just point the focal length, which is 10 on this side. This is 10, this up to here, this is 10 up to here, this is 10 centimeters. Then we will write the 25U here up to here, and automatically the V is calculated is 16.6, which is from here to here. So all the three are calculated in this way, in this numerical. This is V, and these three we have calculated. I think you have understood this question. Now coming to the next question 11. It is also from NCERT. First it is written the lens is diverging. Diverging lens. We know the diverging lenses are concave lenses. So first of all we will write concave lens. First we will read whether it is a lens or mirror. It is lens. We can underline the word lens and then diverging. When it is written diverging, we will write the lens is concave lens. Then the given data we will write. Focal length is written, lens of focal length 15 centimeters. In concave lens, focus is always on the left hand side. So focal length is always negative in concave. So we will write focal length is minus 15 centimeters. Then an image 10 centimeters from lens. What does it mean? It means it is V. It is the distance of image from the optical center. So V is minus 10. Why we have written minus here? Because in concave always the image is formed always on left hand side in front of the lens. Here this red one, red color, this is the image and it is on the left hand side. So we will write the sign negative in front of the image distance. V is minus 10 centimeters. How far is the object? From, how far is the object placed from, not length, from lens. So we have to calculate U. When we have to calculate U, we will not put any sign which is not calculated yet. We will not put plus and minus. Simply we put U, which is to be calculated, and magnification also, m is also to be calculated. So this is the given data. Remember, when we are writing given data, we have to put negative or positive signs in front of the f, v or u. Now this is the formula like this. You know the lens formula. We put the values 1 by minus 10 minus u is to be calculated, f is minus 15. So 1 by u, this is minus 1 minus 1 by u is equal to 1 by minus 15. This whole fraction, it comes on the right hand side. So the sign will be changed, minus 1 by minus 10. This to be cut and this will be a plus. So LCM 30, 15 to the 30, minus 2, 10 3 is a 30. This will be plus, minus minus plus, plus 3. So overall it will be plus 1 upon 30. We will write plus here. Negative we have to write and positive we have to write. We will write plus 1 by 30. So minus u will be 30 or u will be minus 30 centimeters. So in this way we have calculated the distance of object from the lens. It is 30. I have drawn a ray diagram. You see here f is 15 centimeter, v is 10. It is given that the image is formed here, and this 30 we have calculated. So if the object is put beyond, this is on f2, f is 15, this is 30, so this u is f2. If the object is placed at f2 or center of curvature c, then a very small image is formed in front of the lens. We have seen this is one ray which is diverging, this is the second ray, and this diverged ray we have expanded or proceeded up to the focus, and so when it is by dotted line, the image formed is always virtual and erect, because it is not the real image. It seems that this line is intersecting this line on this point. We have proceed this refracted ray behind up to this focal point. So in this way we have calculated u, which is minus 30, because it is on the left hand side of the image. We will write minus here. Now we have to calculate magnification also. The formula is v by u, or we will put the values. V is minus 10, u is minus 30, minus minus plus, so it will be 1 by 3. So the image size is 1/3 of the size of the object, is 1/3 of the size of the object. This is magnification. Now we should draw ray diagram also, taking these values. So this will be the ray diagram of this numerical. You do it in your notebooks, and I think now you have understood all these two numericals, all the other numericals given in the textbook and in the reference book, that is together with, you have to do all the numericals of mirror and lenses. In the next video, we will learn about the power of lenses. This is all for this video. Thank you.